This lesson video is the third in a series on solving quadratic equations by factoring, with a focus on factoring quadratics when a equals 1. In previous lesson videos, we talked about how to ensure that the quadratic is set equal to 0, how to identify a, b, and c, and how to begin using this tool called the x problem to help us factor. In the last video, you learned how to set up an x problem, and in this video, I'm going to demonstrate how to solve the x problem. The learning target states, I can set up and solve an x problem to factor a quadratic. You know you can do this when, given a quadratic expression or equation, you first identify a, b, and c, ensuring that everything is set equal to 0 and all the terms are on the same side of the equal sign. You then draw a large x. You multiply a and c and write the result on the top of the x problem. You write b at the bottom of the x problem. Next, you will list all possible factors of a times c, or what's in the top of the x problem. Then we use the signs of both a times c, or the top of the x problem, and b, or the bottom of the x problem, in order to determine the signs of what we call p and q. We then test each factor pair to find the pair, p and q, which multiply to a multiplied by c, or the top of the x problem, and add to b. Finally, we will write p and q, which are our solutions to the x problem, in the sides of the x. This can be a rather lengthy process, especially if there are lots of possible factor pairs, and involves a lot of trial and error. The goal when solving the x problem is to find two numbers, we call these numbers p and q, that multiply to get the top of the x problem, which is a multiplied by c, and add to get the bottom of the x problem, which is b. Here are some general guidelines to follow. If the top number in the x problem is positive, then we know that p and q have to have the same sign. That's because they must multiply to be a positive value. Now, think of positive, same, positive, same. So if the number in the top of the x problem is positive, your two factor pairs will have the same sign, which gives us two options. They can be both positive or they can be both negative. From there, we look at the sign of b in order to determine what the signs of p and q are. Because if b, or the bottom number, is positive, then p and q are also positive. If the bottom number is negative, then p and q are also both negative. We have another situation that we need to consider, which is that the top number of the x problem could be negative instead of positive. If it's negative, then p and q have different signs. That means one of them is positive and one of them is going to be negative. So, once again, if the top number is positive, think same sign. If the top number is negative, think different signs. With this situation of different signs, we also once again look at b in order to determine which number is which. If b is positive, then the larger of p and q is positive. If b is negative, then the larger of p and q is negative. I always think of it this way: b positive, bigger positive; b negative, bigger negative. As a reminder, here's a visual representation of the x problem with a multiplied by c in the top and then b in the bottom. And what's new is we are now going to not only set it up, but also solve the x problem. And p and q are going to be our solutions to the x or diamond problem. Another way to think of all of this information that's written in the steps outlined above here and the guidelines for solving the x problem is like this, looking at this table. It can be tough to read at first, but you read the table similar to how we would use the table or area model to multiply polynomials or binomials. Therefore, what you do first is you identify a by c as either positive or negative. Notice if a by c is positive, then we simply consider this top row of the table because that's where it says that they are positive or have the same signs. Next, you would look at b and try to determine if b was positive or if b was negative. If a multiplied by c was positive and b was positive, then both numbers, p and q, are positive. If a multiplied by c was positive, but b was negative, then both numbers, p and q, are going to be negative. Remember, you look for the intersection of the two pieces, and that's where your solution lies. So, if I notice that a multiplied by c was negative and b was positive, I would say AC negative, B positive, and note that where they intersect tells me that the larger number is positive, which means that the smaller one would be negative. So you kind of have to play around with the table a little bit and get used to using it to help you figure out the signs of P and Q. I've also written off to the side here a friendly reminder that the top part of this table are considerations we make when we have the same signs, because A by C is positive. And then the bottom is our considerations we make when we have different signs, because A multiplied by C is negative. Let's get a little practice with this. Here are the general steps. We must first ensure that the quadratic is set equal to 0. We will add or subtract terms from one side to the other as needed. We then identify A, B, and C, set up and solve an x problem, AC top, B bottom, listing all the factors of the top number, and then finding the pair that add to the bottom number, using this whole page to help us figure out what the signs are going to be. Finally, it's always a good idea to check to make sure that the solutions, or P and Q, actually work, because it's very easy to make mistakes on these kinds of problems. The directions tell us to set up and solve an x problem for each quadratic. You'll notice that I've already done quite a bit of the work on some of these. We must first, looking at this x quadratic on the left, identify A, B, and C, because everything is already on the same side. A is 1, B is 11, and C is 28. I then multiplied A by C in the top. This time, though, I'm not going to be writing that as much because there's not enough space to write that and the final solution as well. So it's okay to simply write 28, because 1 by 28 is 28. And then B goes in the bottom. Next, off to the side, we list the number that's in the top of the x problem and all of its possible factor pairs. We look at our factor chart, which is printed on white paper, double-sided, in order to quickly, easily, and accurately list all the possible factors. I'm seeing 1 by 28, 2 by 14, and 4 by 7. I'm also going to make sure I write a multiplication dot to remind myself that they're being multiplied to get to 28. Now, we need to take a look at the sign of both AC and B. We'll start with the sign of AC first, and I'm noticing that it's a positive value. If I look back at the previous page, when AC is positive, P and Q will have the same signs. And I need to figure out whether they're both positive or both negative. Well, the chart reminds me that if B is positive, then both numbers are positive. If I look at this particular x problem, I'm seeing that B is a positive 11. Therefore, both of these numbers are going to be positive. So we must now sum or add them all to determine which factor pair gets us the number 11 when we add them. Well, 1 add 28 is 29. That didn't work. 2 add 14 is 16. That also didn't work. However, 4 add 7 is the number 11, and that works. Therefore, the number positive 4 and positive 7 are our solutions to the x problem. So I'm going to write 4 and then 7. Let's take a look at this problem with P. I've already identified that A is 1, B is negative 8, and C is negative 48. I've written A multiplied by C in the top of the x problem, and I've written B in the bottom of the x problem. Next, we list all the possible factors of the top number, which is 48. I'm going to ignore the negative when I list the factor pairs, but then consider the negative when I'm trying to determine the signs of P and Q. 48 has a lot of factor pairs, but as long as I use the chart, it's relatively easy to write them all quickly. Next, we need to figure out what the signs of the factor pairs are going to be, because one of these is going to work. I'm noticing that the top number is negative. And so if I go back to the table on the previous page and say that, hey, A by C, or the top number is negative, I know I need to have different signs. So one of these two situations is going to apply here. Next, we need to figure out what the sign of B is. Well, B is also negative. So I'm going to look in this right-hand side of the chart because B is negative. And I'm noticing that where they intersect is in this box here, which tells me that if AC is negative and B is negative, the larger number must be negative, which means the smaller number is positive. So I'm going to label it as such. The larger number must be negative. Looking at each factor pair, I'm going to label the larger number as negative and leave the smaller number as positive. We're still going to add each of these together. So when you add them in the calculator, and yes, you must test each value to determine which one works, I recommend typing them like this. 1 add negative 48 and 2 add negative 24. You could also write it as a subtraction instead if you wanted, but you must not write it as subtracting a negative because that is not the same thing. As I simplify each factor pair, I'm going to write the solution here. So adding, I get that, 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 and that. And I'm noticing, as I hope you are as well, which factor pair provides us the solution that we need. Obviously, this particular P and Q is the solution to the X problem. So I'm going to write a positive 4 and a negative 12. Lastly, let's check. Let's make sure that 4 multiplied by negative 12 is equal to negative 48. And then also that 4 add negative 12 is equal to negative 8. If I check in my calculator, that's negative 48. That's negative 8. And it checks out. This is the solution to the X problem. Don't forget to do that check at the very end just to make sure that you didn't make any simple mistakes. Let's take a look at this X problem with N. I've already set everything up, so I'm going to go ahead and skip to this part where we list the factor pairs of A multiplied by C. Well, looking at the chart, it's relatively easy to write the factor pairs quickly and in order. In this case, there are 4 different options. And I'm going to keep including that multiplication dot to remind myself that they're multiplying to the top number. This time, the top number is negative once again. However, the bottom number is positive. And in the interest of time, I'm going to consider both at once. So top negative, bottom positive. Top negative, bottom positive. They intersect here in this spot, which means that the larger number is positive and the smaller number is negative. So if the larger number is positive and the smaller number is negative, it would be a good idea to write them like this. Once again, in the calculator, you're going to be adding these. You must add each factor pair, typing in something such as that, writing the solution off to the side. When I add those, I get that, then that, then that, and then finally that. I hope you're also noticing which factor pair obviously works. It's that one right there, which means these are my P and Q, or solutions to the X problem, which I'm going to write here and here. Lastly, I'll check. Make sure that negative 3 multiplied by 10 is negative 30. That checks out. Make sure that negative 3 add positive 10 is 7. Yep, that also checks out. Let's take a look at this problem with an X in it. I've already done the identify A, B, and C and set up the X problem. Now let's solve it by listing all the possible factors of the number 54. Looking at the chart, there are 4 possible options, so I'm going to write them all out. Multiplication dot in between, and then we are going to need to figure out what the signs are going to be. This time, both the top number and the bottom number are negative. So if I look back at the chart, the top number is negative, means I consider the bottom part of the table. Bottom number negative means I consider that part of the table, and they intersect here, telling me that the larger number is negative and the smaller number is positive, which I'm going to indicate like this. I don't really need to write a plus sign in front of all of these because I can tell they're already positive. Now we're going to add them, and similar to this problem up here, make sure you type it in the calculator correctly. either 1 add negative 54 or 1 subtract 54. This case, the result is negative 53. The result there is negative 25. There it's negative 15. And there it is negative 3. Once again, hopefully it's fairly easy to see which factor pair gives us the correct solution. So this P and Q are the solutions to the x problem, a positive 6 and a negative 9. I will check to make sure that works. 6 multiplied by negative 9 is negative 54, and 6 add negative 9 is negative 3. So it looks like we solved correctly. Let's take a look at this one with T. I've identified A, B, and C. Now I'm going to multiply A by C to get the top number, and then write B in the bottom. Off to the side, I'm going to list all the possible factor pairs of 28 using the chart. There are 3 possible options here. Next, I'm going to identify the sign of AC and the sign of B in order to determine the signs of P and Q. They're both negative, so when I look at the chart here, if they are both negative, I'm looking at this section of the chart that tells me the larger number has to be negative and the smaller number has to be positive. So I'm going to note that. Then I'm going to add the factor pairs together to figure out which one gets me the result I'm looking for. Oops, sorry. It's actually going to be negative 27, negative 12, and then finally negative 3. We'll note that that is the correct factor pair. Therefore, that is P and Q, which I will write there and there. Then test it to make sure it works. If I multiply, do I get negative 28? Yes. If I add them, do I get negative 3? Yes. Here, I'm going to demonstrate a little bit more of the process. You'll notice I have not identified A, B, and C yet, but now I have. Multiply A by C, write it in the top, B in the bottom. Next, I'm going to list the AC off to the side and list all of the possible factor pairs of that number using the factor chart. 1 and 16, 2 and 8, and 4 and 4. Now I need to determine the sign of AC and the sign of B to help me figure out the signs of P and Q. This time AC is positive and B is negative. So if I look at my chart here, when AC is positive, I'm looking up here, and B is negative, tells me that both numbers have to be negative. Therefore, in this case, I would do this for each factor pair. I can either type it in the calculator as negative 1, subtract 16, or negative 1, add negative 16. Either of those will work. Do that for each factor pair, and we'll try to figure out which one adds to what we want. You'll notice, hopefully, that that middle factor pair of negative 2 and negative 8 gets us the solution we want. Therefore, those are P and Q. Therefore, they are the solutions to the x problem, negative 2 and negative 8. Let's talk about a couple more complicated problems that require a few more steps where we need to set up and solve an x problem for each quadratic. You'll notice here, first of all, that there's obviously a typo. This should also have an m in it. We would not be able to solve this problem if they had 2 different variables. So please make sure you change that on your notes so that it has an m. And you'll also notice that not all of the terms are on the same side. For example, this negative 42 is all by itself, so I need to move it to the other side by addition. I'm going to write it out in front because it does not have any like terms on that side of the equal sign. That's something we discussed in a previous lesson video. There's nothing to combine the power of 2 with, so I bring it down. I'm treating that first because it's the largest power. Then the power of 1 term next, just bringing it down. And similarly, the linear term with no variable, I'm just going to drop down. Equal to, well, what remains on the right-hand side is 0. Now that all of the terms are on the same side of the equal sign, I can go ahead and identify A, B, and C, set up and solve an x problem. A multiplied by C is positive 42, and then I write B in the bottom. This means that the next step is to write 42 off to the side and list all of the possible factor pairs of 42. According to the chart, that's 1 and 42, 2 and 21, 3 and 14, and 6 and 7. Next, I need to identify the signs of AC and the sign of B in order to figure out what the factor pair signs will be. They're both positive, and if I look back at this table here, both positive lines up here, which means that both numbers are going to be positive. Therefore, what I need to consider is adding each of these to determine which one adds to 13. Well, if I add the first factor pair, I get 43, then the second is 23, third is 17, and the last is positive 13, which is exactly what we want. Therefore, the solution to this x problem, or our p and q, are 6 and 7. I'll check. 6 multiplied by 7 is 42, and 6 add 7 is 13. Let's consider this problem next with the x's in it. Once again, I want to make sure that all of my values, all of the terms are on the same side of the equal sign. So I'm going to add or subtract as needed, making sure whatever I write on one side I write on the other, and that my like terms are lined up. The power of 2 term will come first, then 5x take away 2x is positive 3x, and then 5 take away 59 is negative 54. Going to write the equal sign and note that those canceled, so what remains is simply 0. Now I can identify a, b, and c, set up and solve an x problem. A multiplied by c in the top and b in the bottom. Next, I'm going to list the AC, or the top number, off to the side, and list all of the possible factor pairs of that number. 54 has quite a few. It's got 4 different options here according to the chart. And I'm going to note that those are all being multiplied to arrive at 54. Next, identify the signs. Well, AC is negative and B is positive. So I need to find what the chart tells me to do. If AC is negative, I look down here. Oops, that was the eraser. If AC is negative, I look down here. If B is positive, I look right here, and they line up there. That means the larger number is positive, but the smaller number is negative. So I'm going to make these negative, and I'm going to add each of these together to figure out which one adds to 3. Well, at first I get 53, then 25, then 15, and finally a positive 3. This process may take quite a while of adding and checking each factor pair, but make sure you just work slowly and methodically, testing each value on your own. Negative 6 multiplied by 9 is negative 54, and negative 6 add 9 is indeed a positive 3, so I'm convinced we have the correct solution. Let's take a look at this one next with the t's in it. I'm going to break one of my own pieces of advice, and instead of moving 2 things onto that side, I'm going to move all 3 onto this side. The reason for that is I want to keep the number attached to the power of 2 positive as much as possible. And I know that when I move this to the other side by subtracting it, I will still get a positive 1 for the number attached to the squared term. So I'm going to do that instead. It also means I need to add this 2t to the other side, and notice that I line it up with the other term with the t. And then lastly, I need to move a positive 21 by subtracting it, which I'll write way out in front because it doesn't have any like terms. I want to find the largest power to tackle first, which is 2, so I'm going to do that subtraction piece first, which gets me 1t to the power of 2. Next, the power of 1 term, negative 6t add 2t is negative 4t. And then lastly, the constant term, or the negative 21, I'm just going to write on the end, is equal to, that was 0, 0, 0, so what remains is 0. Now that everything's on the same side of the equal sign, we can easily identify A, B, and C, and set up and solve an x problem. A multiplied by C is negative 21, and then B remains in the bottom. Next, we write negative 21 off to the side, and then list all the possible factor pairs of 21, which is just 1 and 21, and then 3 and 7 according to the chart. Next, I need to identify the signs. They're both negative, so if I look back at the table from a couple pages ago, when they're both negative, we're looking at this part in the table, which tells me that the larger number is negative and the smaller number is positive. This is what it would look like for the larger number to be negative and the smaller to be positive. We add them together to figure out which one is going to work. That's negative 20 and that's negative 4. So obviously it's the second factor pair that gets us the solution that we want. Therefore, the solution to the x problem is 3 and negative 7. Therefore, p and q are 3 and negative 7. I want to draw your attention to a special case over here on the left-hand side, the one with an n in it. You'll notice that all the terms are on the same side of the equal sign, so I can move into identifying a and b and c. It's obvious that a is a 1 because that's the number attached to the squared term. And then if you look, you may notice that that negative 9 is a number all by itself, therefore it's the c term. But you may not remember how to identify the middle term, or the one with the power of 1 attached to it. As a reminder, this could be rewritten as n to the power of 2 add 0n take away 9. We just don't normally write 0 of something because it doesn't make any sense to write it if it doesn't exist. So in this case, the b term, or the b value, is actually going to be 0 because the b term does not exist. The process from here is the same. We multiply a by c, and we write b in the bottom. I'm now going to write the negative 9 off to the side and list all the possible factors of 9 according to the chart. That would be 1 and 9 and 3 and 3. Now I need to identify the signs. Well, I'll notice that the AC is negative, and we're going to call B positive even though 0 is neither positive nor negative. But let's just say the AC is negative and B is positive. Now when it says the AC is negative and B is positive, let me check and make sure that makes sense. Yes, when AC is negative and B is positive, we're looking at this part, which tells me the larger number is positive and the smaller number is negative. That means just make the larger number positive, smaller negative, as such. Now when we're looking at this last factor pair, that was maybe confusing because they're both the same number. So in that case, just make one of them positive and one of them negative. The only thing that matters is that the signs are different. We're still adding these together to figure out which one E adds to 0. That's going to add to a positive 8, and that is going to add to 0, because negative 3 add 3 is 0. So you can see easily now which factor pair gets us the result we want. It's negative 3 and 3, which are the solutions to the x problem, and which are P and Q. So that special case there sometimes throws people off. You'll notice if the B term is ever non-existent or at 0, what's going to happen is the correct factor pair is going to be the same number with one of the values as positive and the other as negative. So without even doing this one, I can tell you that the solution to that x problem is going to be negative 4 and positive 4, because 4 is the only number that multiplied by itself gets 16, and one positive, one negative will result in a B value of 0 and an AC value that is negative. So hopefully this lesson video showed you a little bit about how to solve the x problem.